So, welcome back to differential calculus class. So, in this class, we'll be talking about partial derivatives and particularly chain rule. So, if we are given a chain function, that is the function of function, composite function, that involves two independent variables, and we have to find the partial derivative of the dependent variable with respect to each of the independent variables we are given. So let's assume we have a function z is equal to f of x, y, okay, and this function itself now raised to power n. So where n here is a real number. Okay, so how do you find the partial derivative of z with respect to x and y? So it's very simple. The chain rule states that the partial derivative of z with respect to x will be equal to, you bring down the power, that is n, and you multiply it by the original function. So we have f x y. Then you subtract 1 from the power, then you now multiply by the derivative, that is the partial derivative of f, this whole function with respect to x. Also, the partial derivative of z with respect to y will follow the same format. So we have n, we have f of x, y, then n minus 1, then we have partial derivative of f with respect to y this time around. So it's very simple. This word changes. So let's take a look at this example and apply this rule. Let's say we are given this function, given z equals to what? Let me check one question here. X raised to the power 3, x raised to the power 3 plus 7y squared raised to the power 4. And we are asked to find the partial derivative with respect to x and y. So how do we find that? It's very simple. So solution. So here is the original question, z equals x raised to the power 3 plus 7y squared everything raised to the power 4. So the partial derivative of z with respect to x will be equals to, you say you bring down the original function. When you bring down the original function, so we have 4, then we have x raised to the power 3, just have to study this, plus 7y squared. Then we have 4, you subtract 1 from the power, then you multiply by this with respect to x. That is, you are going to find the derivative of the function you have in this bracket. In other words, you have your f. If your f here, this function f here you have here as f of x, y, then in this y is equal to x raised to the power 3 plus 7y squared. Okay, so in other words, the f, that is the partial derivative of x raised to the power 3 plus 7y squared dx. Okay, that's what it means. Then we have for into bracket x raised to the power 3 plus 7y squared, then everything raised to the power 3 now. Okay, we differentiate this with respect to x. So because this one does not contain x, you ignore it, you only differentiate this part. Remember the additive function rule. So you differentiate x raised to the power 3, that gives 3x squared. Okay, so this can be simplified further to be this 3x squared, you multiply by 4, so this gives 12x squared, then to bracket x raised to the power 3 plus 7y squared raised to the power 3. So this is the partial derivative of z with respect to x. So we also need to find the partial derivative of z with respect to y. So to do that, we follow the same process. So the partial derivative of y with respect the value of z with respect to y will be equal to, you bring down the power. Look at this one. You bring down the power, you have 4. Then you have the function itself. In the bracket, you have x raised to the power 3 plus 7y squared. You have 4 minus 1, right? Then multiply by the partial derivative of what we have here in the bracket, f. So we have x raised to the power 3 plus 7y squared. Then you have dy. So this is equal to 4 to bracket x raised to the power 3 plus 7y squared. Then we have raised to the power 3. Then you multiply. So when you differentiate this with respect to y, so you are looking for y, this is the recurrent variable. So you ignore this, so you only differentiate this. So you differentiate this 7y squared. That gives, you bring down the power, you multiply by the coefficient, that gives 14y. Okay, then you can simplify further. 4 multiplied by 14y, 56y into bracket x raised to the power 3 plus 7y squared. Everything raised to the power 2. So this is the partial derivative of z with respect to y. So now, can you now try this and drop your answer in the comment section? Let's say we are given z, this function z equals to, let's say we have x raised to the power 4, let's say 2x raised to the power 4 plus 5, y raised to the power, let's say 3. So can you find the partial derivatives? So try this.